Question. A car heading east turns right at a corner. The car turns at a constant speed of 20 meters per second. After 12 seconds, the car completes the turn so that it is heading due south at 20 meters per second. Calculate the car's average acceleration. First, let's review a knowledge. This is vector d1, and this is vector d2. And we draw a vector from the end of d1 to the end of d2. Now, this new vector is just d2 minus d1. Then let's go back to the question. I draw the graph. This is just the velocity, initial velocity, and this is the final velocity. Because this direction is east, and this direction is south. The car heads east initially, then it turns, then it heads due south. Then this vector is just the final velocity minus the initial velocity. And this angle is theta. This is a right angle. So from the graph, we can know that the magnitude of the final velocity minus initial velocity just equals square root the magnitude of final velocity square plus the magnitude of initial velocity square equals. We know the magnitude of the final velocity and the initial velocity are all 20 meters per second. So this is square root 20 square plus 20 square. And this equals 28.48 meters per second. And the angle theta equals arc tan theta. The magnitude of the final velocity over the magnitude of the initial velocity. And this equals arc tan theta 20 over 20. And this equals 45 degrees. Then we can know that the velocity change, the final velocity minus initial velocity, is just 28.28 meters per second. The direction is west 45 degrees toward south. It's because this direction is west and this direction is south. So it's west 45 degrees toward south. Now we can know that the average acceleration just equals the change of velocity, the final velocity minus initial velocity over the time interval. And this equals 28.28 over 12 and equals 2.36 meters per second square. The direction is the same as the change of the velocity, west 45 degrees toward south.